So this is the code that we just saw. What's happening here? Again, same story. At first, we're creating a children object. This is a string type array, and it has these three things stored in it. We're then assigning that to children here. So again, let's draw the diagram. This is our memory, let's say. A small part of the memory is the children array, and it has Mary, David, and Eric stored in it. And let's say that's the address of the array. We have a 32-bit memory where basically children variable stores the address, and it points to this object. Great. We now send that to children here, and this has the same address. This address goes here, and then that comes here, which ultimately comes here, and then it gets copied to a new array. So let's say that new array object is here. And this new array gets created and gets assigned to children. This children is basically this children, and this children is basically this children. So this is from the main class, and this is from the person class. What's the value that it stores for this new array that it's getting assigned to? The same address as the new array, and then it points to this array. After that, on this line, everything gets copied. So this has Mary, David, and Eric. All encapsulated, all good. If we change children, nothing would change for our person class's children. So this is encapsulated. This has its own object. Very good. So that's what has happened up till now, up till this point. Now we come here. So this is a new variable that's being created. So let's say we create the new variable here. This is outside array. Great. So what's happening? It says get the value of p1.getChildren. Great. So p1.getChildren is a method. So it comes here. And here it just returns a string type array, which is children. So it just returns children, which means it returns whatever value is stored here. The value stored here is this, right? So that's the value that's stored in children. And this value is getting returned to this method. So that means outside array now has a value which is the same as children from our person class. That means this is getting assigned here. And what is this address pointing to? This is pointing to this object. So you see, it's almost like hijacking. I have hijacked the address of an internal variable using my getter method. And now I have that reference in outside array. Now, if I change outside array, I know that children will change because they're pointing to the same object. So when I actually changed outside array's first element to Bugs Bunny, what happened is that it came to the same object and changed this to Bugs Bunny, which means that it is able to change my children variables object. And this children variable is from the person class. So this needs to be encapsulated, but this is not encapsulated. I can hijack this value using my getter method, and I can directly now know the address where this object resides, and then go and do whatever I want to that object using the outside array variable. And that is not good. So what can we do? We can definitely not do this. This is wrong because this breaks encapsulation. This means that encapsulation is being broken for our non-primitive variables. So we cannot do this. What we should do is the same solution. We should make a copy. So at first we should create here, a copy. We should create a new array object named copy, which will be of string type, and we'll use the new keyword and then create this object using the length of this variable. So how does this look in memory? So let's remove this since this is not what's happening anymore. When the program comes here, outside array gets created, right? And this memory gets allocated. And then it says, what should I put in here? It actually looks into this method. So the program comes here and then it sees that a new array is being created named copy. So let's create that. So a new array gets created. Its name is copy, this variable, and the object is somewhere here. The object has the same length as the children. The children has 3. Of course, this would not also happen right now, right? There you go. So the children variable from the person class has a length 3. So if we say that's the length of the new array copy as well, so this will also have a length of 3. There would only be 3 slots here. So let's say this is the new address of this empty array, and this address will then be stored in copy, and then this would point to this object. And then what we should do is copy everything from children to copy. So here we should write the same thing as here. We should write system.array copy. And where are we copying from? We're copying from this dot children, right? So we'll say this dot children. We'll start from the 0th position of this dot children. We'll copy it to the copy array that we just created. And we'll also start from 0 for copy. And we'll do it until you reach this dot children's length. And in the end, we just return our copy array. So now what's happening is that a new copy is being created. This is a new array. And this is how it looks in memory. And then everything from this dot children gets copied to here. So now this gets copied, and then this gets copied as well. And so we now have Mary, David, and Eric in this copy array. And then we return the copy, right? So here, outside array does not get this address because now we're not returning children directly. We are returning the copy, which means that outside array gets this address. So this would change. So this address is what's stored in outside array. So when I change the first element of outside array, it's actually changing this element here and making it Bugs Bunny. Our children variable that is part of the person class is safe from any changes from the outside because now outside array is actually getting this address and it's pointing to this array. So whenever we make any changes to outside array, this array gets changed, not the array that we want to protect. So that is how we should also fix all of our getter methods as well. For children, for age, for gender, for any of the variables that you have in your class. So that takes care of encapsulation. You understand what encapsulation is. We want to protect all of our data. We want to protect all of our variables and methods from any outside change, and we don't want our class to leak. Our class is also our container. And this container needs to be leak-proof and completely protected. That's encapsulation. But there are some problems with getters and setter methods. And we've seen what those problems are. We've also seen how to solve them. We've also seen that constructors can have the same problem. And we've solved that problem using the setter methods in constructors. We also now know that we should always use access modifiers to make sure that we can protect our variables from any outside unwanted change. So all of this should give you a basic understanding of what encapsulation is.